So today we're going to talk about capacitors. So what are capacitors? Well, capacitors are electrical components in a circuit that can store electrical energy and then release it when you need it in the circuit. We have two major types of capacitors. We have fixed capacitors and we have variable capacitors, and we'll be talking about both in the next few slides. So how do fixed capacitors work? Well, in all capacitors, we have two metal plates separated by an insulator. In this case, it is air. And we'll connect this to a battery so we can charge the capacitor. And the battery, we have a lot of electrons in the negative terminal and no electrons in the positive terminal, since it's positive. And in all parts of the wire, including these two metal plates, we have a lot of electrons and protons. And we have the same number of electrons as protons, giving it a neutral charge. So both of these two plates have a neutral charge, not negative, not positive. But guess what happens when we start pumping in electrons from the battery? What's going to happen to this plate? It's going to have a negative charge, since electrons are negatively charged. So it's going to have a negative charge. And the negative charge that's formed from this plate is now going to repel the electrons in this plate. And since electrons are negatively charged and negative repels negative, it's going to repel them and they're going to attract the positive terminal, since negative attracts positive, the positive terminal of the battery. And so now, since this is more protons, here we have more electrons, here we have more protons, this gives this plate a positive charge. So we have a neat little formula to explain how good a capacitor is in storing charge. And so C in this formula stands for capacitance. And capacitance is measured in farads, named after the English physicist Michael Faraday. And we have two measurements. We have a lot of measurements. Some of these are microfarads. We have 1 million microfarads in a farad, and we have nanofarads. We have 1,000 nanofarads in a microfarad. Now we have Q. And Q is measured in coulombs, and it's basically charge, the amount of charge stored. And so in this plate, we have, if you add up all the ones and protons give positive 1 and electrons give negative 1, you get 7 in this plate and negative 7 in this plate. And Q, it doesn't matter which plate you pick, you have to pick one of these plates. If you pick, you can pick 7 or negative 7, but Q would be the absolute value. So the absolute value of negative 7 would be 7. So Q in our case is 7. And then we have V. V is measured in volts, and it's basically a voltage. And so you could think of voltage as the tendency, or how much the electrons want to get from the negative terminal to the positive terminal, or the force. It's basically the force, and in our battery, it's 1.5 volts. And so it's the force that the battery is going to push the electrons to get from the negative terminal to the positive terminal. And in our battery, it's 1.5 volts. So the capacitance of this capacitor would be 7 by 1.5. So now let's see how we can change the capacitance by changing the physical characteristics of the capacitor. So we can change the distance between the two plates, and this would change the capacitance. See, if you put a battery and pump in electrons, we're going to get a negative charge into this plate, right? But this negatively charged field is not going to be able to push the electrons out of this plate to make it positive. And so Q is going to decrease, since the charge would decrease, because we are not going to be able to push as much electrons. And when Q decreases, C will decrease. So when we increase distance, we decrease capacitance. Another of these factors is area. If we increase the area of the two plates, then we have more space to store the charge, and therefore we increase Q. And when we increase Q, we increase C. And so when we increase area, we increase capacitance. Another of these factors is the insulator. So far, the insulator has been air. And air is the best insulator, but in different capacitors we have different insulators. In some capacitors we have plastic, and depending on how good this insulator is, we can change the capacitance. If the insulator is really bad, then the electrons will flow through and most of the charge won't be stuck, so our capacitor Q would decrease since most of the charge wouldn't stay in the two plates, and then therefore capacitance will decrease. Back to our capacitor. So we charged our capacitor, so now we can discharge our capacitor. So we have negative terminal and the positive terminal, and we can do this very much like a battery. The electrons in the negative terminal will attract the positive terminal, so they go across the circuit, light up the bulb throughout the way, and get to the positive terminal. So all will do this, and then our two plates will get back to neutral. Fun fact time! Did you know that the first capacitor was invented in 1745? Okay, so now let's talk about how variable capacitors work. And so variable capacitors use the advantage, as we said before, the advantage of the fact that when we change the distance and change the area, we can change the capacitance. And in variable capacitors, the capacitance is variable. In fixed capacitors, the capacitance is fixed. And so we can change the distance between the two plates, as you can see here, and we can change the capacitance. We can also change the area, and so you could think of it like this. We can overlap the plates. So let's say we have one plate, and we have another plate, and if you want to increase the area, all we have to do is slide this plate here, and the area will increase. And so we can increase and decrease the area, and that will be another factor in increasing and decreasing the capacitance. So what are capacitors used for? Well, we can use capacitors in many ways. One example is when you have a heart attack, use something we call a defibrillator. So doctors use something we call a defibrillator. And basically, a defibrillator has a capacitor. And so you have your patient, and so you charge your capacitor with electrons in the negative terminal, and you have your patient, and basically what the capacitor will do is give a small shock, not as big as a battery would, but just a small shock to your body. And so heart attack is when your heart is beating irregularly. And when you pump in these electrons and give your body a small shock, hopefully your heart will get back to the correct rhythm. So I hope you enjoyed this video. Thank you for watching. I have my resistors video here, and I have my batteries video over here. So be sure to watch them. Bye!